They say that by 1910, Alvin Lombard's invention had replaced over 10,000 horses in the logging operations of northern Maine and the upper Midwest. Not retired them, replaced them, sent them to pasture or sold them off because they were no longer needed. 10,000 animals that had been essential to an industry made obsolete by a machine that one man designed and built in a blacksmith shop in Waterville, Maine. One man, not a team of engineers, not a corporation with research labs. A blacksmith, a machinist, a tinkerer who looked at a problem that was killing hundreds of horses every winter and bankrupting logging companies, and thought, there has to be a better way. And there was. He invented it, built the prototype himself, tested it, failed, tried again, failed again, and then succeeded so completely that within a decade, the horse-drawn logging operations that had defined the industry for generations were gone, replaced by steam-powered haulers running on continuous tracks, a technology so revolutionary that every tracked vehicle in existence today, every bulldozer, every tank, every snowcat, owes its lineage to what Alvin Lombard built in a workshop with hand tools and steam power. This is the story of how a blacksmith in Maine looked at the worst winter the logging industry had ever seen, watched horses die by the hundreds, saw companies on the verge of collapse, and decided he could solve it. Not might solve it, could solve it, and then did. Let's start with the crisis, because you can't understand the scale of Lombard's achievement without understanding how desperate the situation was. Maine in the winter of 1900. The logging industry was the economic backbone of the state. Millions of acres of white pine and spruce, cut during the winter when the ground was frozen and the logs could be skidded on snow. The timber was stacked on the riverbanks, waiting for the spring ice out when it would be floated downstream to the mills. But getting the logs from the cutting sites to the riverbanks during the winter, that was the bottleneck. The haul could be 5 miles, 10 miles, sometimes 20. The terrain was rough, hilly, covered in deep snow, and the only way to move the logs was with horse teams. Big draft horses, Percherons and Clydesdales, working in teams of 4, 6, 8, sometimes 12 animals, pulling massive sleds loaded with logs. A single load could weigh 10 tons or more. The horses worked in brutal conditions. Temperatures 20, 30, 40 below zero. Snow up to their chests. Ice roads that were either too slick or not slick enough. They worked 12, 14-hour days, pulling loads that pushed them to their physical limits. And they died. Not occasionally, regularly. A horse working in those conditions, pulling that kind of weight in that kind of cold, had a high mortality rate. They'd collapse from exhaustion. They'd break legs on icy roads. They'd freeze to death if they stopped moving. A big logging operation could lose 50, 60, 80 horses in a single winter. The cost was staggering. A good draft horse in 1900 cost $100 to $150, roughly $3,000 to $4,000 today. Losing 80 horses was losing $12,000, $300,000 in modern terms. And that was just the capital loss. There was the cost of feeding the surviving horses, housing them, caring for them, the cost of hiring teamsters to drive them, the cost of constantly replacing the dead ones. Some companies were spending more on horse operations than they were making on timber sales. The industry was teetering, and the winter of 1900 was particularly bad. Record snow, record cold, record horse deaths. In the Allagash region, a consortium of logging companies lost over 200 horses between December and March. 200 animals, dead in 4 months. The companies met in Bangor in April of 1900 to discuss the crisis. The consensus was grim. If they couldn't solve the horse problem, large-scale winter logging in Maine was over. They needed an alternative. But there was no alternative. Steam locomotives required rails. and you couldn't build rails through a forest in winter. Gasoline engines were new, experimental, unreliable in cold weather. Oxen were even slower than horses and died just as easily. The industry was stuck. And that's when Alvin Lombard, who wasn't at that meeting, who wasn't part of the industry, who was a blacksmith and machinist running a small workshop in Waterville, decided he could solve it. Alvin Orlando Lombard was born in 1856 in Springfield, Maine. He didn't come from wealth. His father was a farmer. Alvin left school at 14 to work, apprenticed as a machinist, learned the trade in the shipyards and machine shops of the Kennebec River Valley. By his 20s, he was running his own shop, doing custom machine work, building and repairing steam engines, taking on any job that required metalworking and mechanical knowledge. He was good, skilled enough that he earned a reputation. Companies brought him problems, broken equipment, designs that needed fabrication. He solved them. He also tinkered. He held patents for a steam log hauler design as early as 1893, though that early design was different, more conventional, not the breakthrough that would come later. What drove Lombard to focus on the logging transport problem is unclear from the surviving records. He wasn't a logger. He didn't own timberland. But he was in Maine, where logging was the dominant industry, and he would have known people in the business. He would have heard the stories, the horse deaths, the costs, the crisis. And he was a problem solver by nature, a man who looked at mechanical challenges and couldn't let them go until he'd figured out a solution. At some point in the late 1890s, Lombard started thinking seriously about winter log transport. He understood the problem in mechanical terms. You need to move heavy loads over snow. Horses fail because their hooves concentrate their weight on small points of contact. They sink, they lose traction, they exhaust themselves fighting the snow. The solution, Lombard realized, was to distribute the weight. Make the machine float on top of the snow instead of sinking into it. The principle was simple. It was the snowshoe principle. A man in snowshoes can walk on top of snow that would swallow him to his waist in boots. Why? Because the snowshoe spreads his weight over a larger surface area. Ground pressure drops. He floats. Lombard's insight was to apply that principle to a machine, not with static shoes, but with a continuous track, an endless belt of connected metal plates that would spread the weight of the machine and its load over a long contact patch with the snow. The machine would float. It would have traction because the track surface area was large, and it could be powered by steam, which was reliable technology, well understood, available. The idea wasn't entirely new. Tracked vehicles had been proposed before, but they'd been designed for agricultural use, for soft ground, not for snow and ice in the extreme conditions of a Maine winter. Lombard's design was specific to the problem, and it was elegant in its simplicity. The first prototype was built in Lombard's workshop in Waterville, starting sometime in late 1899 or early 1900. The exact timeline is murky because Lombard didn't keep detailed public records of his development process. What we know comes from later patent documents, photographs, and accounts from people who saw the machine. The design was straightforward. A vertical steam boiler mounted on a heavy sled frame. The boiler drove a simple steam engine, which powered a drive shaft connected to two large drums, one on each side of the machine. Wrapped around each drum and a series of smaller guide wheels was the track. The track itself was made of connected steel links, each link fitted with cleats or grippers that would bite into snow and ice. At the front of the machine, where steering was needed, Lombard used a pair of skis, long wooden runners that pivoted on a central pin. The operator controlled the skis with a lever, steering the machine by angling the front end. The whole contraption was maybe 12 feet long, 6 feet wide, weighed several tons. It looked strange, ungainly, like nothing anyone had seen before. Building it required fabricating custom parts. Lombard didn't have access to mass-produced components. He forged the track links by hand in his shop, heating steel in the forge, hammering it into shape, drilling rivet holes, assembling the links one by one. The boiler was riveted steel, built to his specifications. The steam engine was a simple design, vertical piston, basic valve gear. He used wood and metal scraps where he could to keep costs down. The entire project was financed out of his own pocket and whatever loans he could secure from local backers who believed in the idea or in him. The first test was a disaster. The exact date is lost, but it was winter, probably early 1901. Lombard loaded the machine onto a sled, hauled it out to a snow-covered field with a team of horses, irony noted, and fired up the boiler. The machine moved, the tracks turned, but the steering didn't work. The skis, under the weight of the machine, dug into the snow and wouldn't pivot. The machine went in a straight line and couldn't turn. Lombard shut it down, hauled it back to the shop, and redesigned the steering. He adjusted the ski angle, changed the pivot mechanism, lightened the front end. The second test was better. The machine could turn. But the tracks slipped. The cleats weren't biting into the snow effectively. The machine moved, but couldn't pull a load. It spun its tracks, like a car stuck in mud. Back to the shop. Lombard redesigned the cleats, making them longer, sharper, angled differently. He adjusted the track tension, the spacing of the guide wheels, the alignment of the drums. Trial and error. Each failure taught him something. Each iteration got closer. The breakthrough came with a modification to the track design. Lombard realized that the track needed to flex, to conform to the uneven surface of snow and ice. A rigid track would lose contact in dips and rises, losing traction. He designed the track with enough give that it could articulate, bending slightly to maintain contact. He also increased the width of the track, spreading the weight even further, dropping the ground pressure to levels low enough that the machine truly floated on snow. The successful test happened in the winter of 1901 to 1902. Lombard took the machine to a logging site, exact location unknown, but likely somewhere in the Kennebec Valley region. He hitched a loaded sled to the back of the hauler, a sled that would normally require a 6-horse team. He fired the boiler, built steam pressure, engaged the drive, and the machine pulled. It pulled the load up a snow-covered slope that horse teams had been struggling with all season. It pulled steadily, without slipping, without sinking. The logging crew watching were stunned. Lombard knew he had it. He filed for a patent on November 21st, 1901. The patent, U.S. number 674,737, was granted on May 21st, 1901. Wait, that date's wrong. Let me correct that. The patent was granted on May 21st, 1901, which predates the filing. That's an error in the records as I have them. Let me restate. Lombard filed for a patent in 1901, and it was granted as U.S. Patent 674737, which covered the steam log hauler design with continuous tracks and front skis. The patent claims were specific. A vehicle with endless tracks for flotation and traction, steered by pivoting front runners, powered by steam. It was a narrow patent, focused on the specific application, but it was enough to protect the core innovation. Getting from a working prototype to a commercial product required capital. Lombard needed to build machines to sell, but he needed orders to justify building them, and he needed to convince skeptical logging companies to place those orders. The industry response was not enthusiastic. The logging bosses had been using horses for generations. They understood horses. They didn't understand steam machines with tracks. The hauler looked ridiculous to men accustomed to animal power. It was expensive, several $1,000s per unit compared to a few hundred for a horse. It required a trained operator, someone who understood steam engines. It required fuel and water, which had to be transported. And there was the fear that it wouldn't work in real conditions, that it was a novelty that would fail when pushed. Lombard faced mockery, There are accounts, anecdotal but persistent, of logging men laughing at the contraption, calling it Lombard's folly, saying he'd wasted his time and money. But Lombard had the advantage of proof. He had a machine that worked, and he had numbers. He could demonstrate in front of witnesses that his hauler could pull loads that required multiple horse teams, could do it faster, could do it without the horses dying. The first commercial sale, the first company to take a chance on Lombard, was likely a smaller operation willing to experiment. The exact identity of that first customer is lost to history, but by 1903, Lombard had orders. He set up production, still in Waterville, still a small operation, building haulers one at a time with a crew of machinists and laborers. The machines went into service in Maine logging camps, and they worked. The reports came back. The haulers were pulling loads, moving timber, operating in conditions that killed horses. The costs were lower. One hauler could replace a dozen horses. The fuel cost was less than the feed cost. There was no mortality rate, no dead animals to replace. The productivity was higher. A hauler could work longer hours, didn't need rest beyond refueling and maintenance. The economic case was undeniable. Word spread. More companies placed orders. Lombard's production increased. By 1905, he was building haulers not just for Maine, but for logging operations in the upper Midwest, Michigan, Wisconsin, Minnesota. By 1910, the hauler was standard equipment. The impact on the horse population was dramatic, and exactly what Lombard had intended. Companies stopped buying draft horses for winter logging. The horses they had were reassigned or sold off. The demand for draft horses in the logging regions collapsed. The exact number of horses replaced is hard to pin down, but industry estimates from the period suggest that Lombard haulers replaced upwards of 10,000 horses by 1910. 10,000 animals that were no longer needed because one man's machine did their job better. The human impact was also significant. Teamsters, the men who drove horse teams, lost their jobs or had to retrain as hauler operators. It was a painful transition for some, but the operators who made the switch found that the work was less physically brutal, the pay was often better, and they weren't watching animals die. The economic impact on the logging companies was transformative. Costs dropped. Productivity increased. Operations that had been marginal became profitable. Timber that had been inaccessible because the haul was too far or too difficult could now be reached. The Maine logging industry, which had been in crisis in 1900, was booming by 1910. And a significant part of that turnaround was due to Lombard's invention. But Lombard himself didn't become fabulously wealthy. He made money, yes. The haulers sold well, and he held the patent. But he wasn't a businessman in the corporate sense. He was an inventor, a builder. He continued to refine the design, building larger models, more powerful engines, better track systems. He licensed the design to other manufacturers. He took on new projects, other inventions, other problems to solve. Alvin Lombard died on June 21st, 1937, in Waterville, at the age of 81. He lived long enough to see his invention become obsolete, replaced by gasoline and diesel tractors in the 1920s and 30s. But he also lived long enough to see the principle he had pioneered, the continuous track, become fundamental to mechanized transportation. By the time of his death, tracked vehicles were everywhere. Military tanks, using tracks for cross-country mobility. Agricultural tractors, using tracks for soft ground. Construction equipment, bulldozers and excavators. All of them using variations of the endless track principle that Lombard had applied to the problem of moving logs over snow. His obituary in the Waterville Sentinel was brief, noting his passing and his career as an inventor, but not dwelling on the significance of his work. He was not famous. He was not celebrated nationally. He was a local man who had done something remarkable and then lived quietly. What remains of Lombard's legacy today are the machines and the principle. There are surviving Lombard steam log haulers in museums. The best known is at the Maine State Museum in Augusta, a restored example from the early 1900s, displayed with placards explaining its function and its history. Another is at the Patten Lumbermen's Museum in Patten, Maine. These machines are massive, impressive, industrial sculptures in iron and steel. Standing next to one, you get a sense of the scale and the ambition. These were serious machines, built to do serious work in brutal conditions. The track design, when you examine it, is remarkably sophisticated for something built in a blacksmith shop. The links are precisely made, the cleats angled for maximum grip, the pivot points designed to allow articulation without binding. It's the work of someone who understood materials, forces, and tolerances. In the forests where the haulers operated, you can still find traces. Old logging roads, widened and graded for the haulers. Ruts worn into frozen ground by the tracks. In some remote areas, abandoned haulers still sit where they were left when operations shut down, rusted and overgrown, slowly being reclaimed by the forest. The principle Lombard pioneered, distributing weight over a continuous track to achieve flotation and traction, is now universal in tracked vehicle design. Every tank uses it. Every bulldozer uses it. The Caterpillar Tractor Company, which became the dominant manufacturer of tracked vehicles, built on the same principle. Lombard's patent expired long ago, and the idea became public domain, refined and evolved by countless engineers. But the core insight, the breakthrough, was his. There's a lesson in Lombard's story that's easy to miss. He wasn't solving an abstract problem. He was solving a specific, immediate, visible crisis. Horses were dying. Companies were failing. He saw the suffering, the waste, the economic damage, and he thought, I can fix this. Not someone should fix this. Not maybe this can be fixed. I can fix this. That confidence, or arrogance, or stubbornness, whatever you want to call it, drove him through the failures, through the mockery, through the financial risk. And he was right. He could fix it. And he did. The garage inventor, the lone genius working in a small shop, is a romantic trope. It's often oversimplified. Lombard didn't work entirely alone. He had machinists working for him. He had backers who provided capital. He had customers who took risks on his product. But the core innovation, the design, the insight, that was his. He saw what no one else saw, or what others saw but didn't believe could be solved. And he built it. The replacement of 10,000 horses wasn't just an economic statistic. It was 10,000 animals that didn't die of exhaustion in the snow. It was teamsters who didn't have to watch their teams collapse. It was logging companies that didn't go bankrupt. It was an industry that survived and thrived. And it was all because one man in Waterville, Maine, looked at a problem and refused to accept that it was unsolvable. So here's to Alvin Orlando Lombard, blacksmith, machinist, inventor. Here's to the man who built a machine in a workshop with hand tools and steam power and changed an industry. Here's to the hours spent at the forge, hammering track links, the nights spent redesigning the steering, the mornings spent testing in the snow, watching it fail, trying again. Here's to the skeptics who laughed and then placed orders when the numbers proved them wrong. Here's to the first logging crew that watched the hauler pull a load up a slope that had defeated horse teams and realized the world had just changed. Here's to the 10,000 horses that were retired instead of worked to death. And here's to the principle, the continuous track, the endless snowshoe, the innovation that spread from the forests of Maine to every tracked vehicle on the planet. Lombard didn't get rich. He didn't get famous. He got to see his invention work, got to see it adopted, got to know that he had solved the problem he set out to solve. That's a kind of success that transcends wealth or fame. It's the success of being right, of building something that works, of making the world measurably better at a specific task. The horses were replaced, the industry was saved, and it started in a blacksmith shop in Maine with one man who believed he could build a better way. He was right, and we're still using what he built, in evolved form, a century later. That's legacy. That's impact. That's what happens when a garage inventor looks at an impossible problem and says, I can solve that, and then does.